going to start by taking my substitution and I'm going to differentiate it. To help me to do that, I'm just going to rewrite that sine squared as sine theta squared like that, just to make it super clear that I'm using the chain rule here, where I'm going to differentiate the squared part first. So we're going to times the 4 by the 2 and take 1 away from the power. And now by the chain rule, I have to multiply that by the derivative of the inside. The derivative of sine is cos. So my dx by d theta is 8 sine theta cos theta. So I can then rearrange to make dx the subject. It will be 8 sine theta cos theta d theta. Which means I can then replace my dx with all of this. Next, let's talk about these limits. What are those limits in the theta world? So when x equals 3, remember that x is 4 sine squared theta. So if I divide both sides by 4, and then square root both sides, then do sine inverse of the root 3 over 2, I get pi over 3. So when x is 3, theta is pi over 3. So that shows why that's become that. Next, what about when x was 0? Let's show that. So again, divide the 0 by 4, we still get 0. Square root 0, we still get 0. And sine inverse of 0 is 0. So that explains the lower limit. Right. So we've got our upper limit of pi over 3. We've got our lower limit of 0. Let's get cracking into that square root. So we've got the x on the top, which we know is equal to 4 sine squared theta. On the bottom of this square root, we've got 4 minus x, so 4 minus sine squared theta. And let's not forget that I've changed that dx to be an 8 sine theta cos theta d theta. Right, let's look at this square root in a bit more detail. On the denominator, I've got 4 minus 4 sine squared. Now, I can rewrite that. So, if I were to factorise the 4 out, I would have that. And this 1 minus sine squared here is the same thing as cos squared. So my denominator is going to turn to 4 cos squared. So just to repeat, that 4 minus 4 sine squared has turned into 4 cos squared. Which is helpful because these 4s are going to cancel out now. Then I'm left with the square root of sine squared theta over cos squared theta times 8 sine theta cos theta d theta. Now, square rooting these sine squared and cos squareds, well, they're just going to cancel out. The square root of sine squared over cos squared is just sine over cos. And just giving myself a little bit more room, in fact actually loads of room down here. Because I can now see that this cos here and this cos here are going to cancel out. And just leave me with sine theta times 8 sine theta d theta, or 8 sine squared theta d theta. And just to make this look like what we wanted at the beginning, I can factorise an 8 outside, so lambda is 8 in this question. And there we go, that's question 25 done. We have shown with all of the steps how the substitution x equals 4 sine squared theta turns that integral in the x world into that integral in the theta world. Question 26. Find the integral of x squared e to the x. I'm going to use integration by parts to do this. I'm going to say that u is x squared, and I'm going to say that v dash is e to the x. Differentiating by x squared, I get 2x. Integrating e to the x, I get e to the x. So, applying the by parts formula, I've got u times v minus the integral of u dash times v. Now, in order to integrate this part, well, I'm going to need to use by parts again on this. So, let's use red pen for this integral here. I'm going to say that u is the 2x, and v dash is the e to the x. So u dash is 2, and v is e to the x. Right, applying the by parts formula then, we've got the u times the v minus the integral of the u dash times v. And now, finally, after all of this, I've got this integral in a form that I can actually integrate. So let's do that. Let me copy down everything else that I've got there. Okay, the integral of 2e to the x is going to be 2e to the x. And now I'm just going to be careful with these brackets. I've got the minus 2xe to the x, and then the minus to minus, that will be a plus 2e to the x. And the only other thing I might want to do is factorise the e to the x outside. I don't have to, the question doesn't say I have to, but it's a good habit to get into. And there we go.